In this video, I will explain why combined footings are always doubly reinforced and why isolated footings are usually singly reinforced. You will also learn the key reason why we must reinforce the tension zone in any concrete element. If you have ever wondered how reinforcement resists failure and ensures structural stability, this video will give you a solid understanding. I'm Miracle Okeke Richard. Welcome to SamGoz Engineering, and here I help you develop the required skills and enhance your knowledge to elevate your engineering career. So if this is what you want, you can quickly subscribe. I will start by first explaining the basics, which is why must the tension zone in every beam be reinforced. As we all know, if a uniform distributed load or even a point load is being applied to a beam, that beam will be subjected to tension and also subjected to compression. Look at it, the bottom part will be subjected to tension, while the top part will be subjected to compression. What do we mean by tension? We mean by tension in the sense that it will be stretched apart, and compression in the sense that they will be coming together. And as we all know, concrete beams or concrete in general is totally weak in tension. So because once it is being subjected to tension, it will stretch apart, and which will result to failure. So for that reason, in every beam, we always reinforce the tension zone, because concrete is very weak in tensions, and once a beam is being subjected to any load, this tension zone is prone to failure. So that is why in all our beam, we always reinforce our tension zone. Then coming over to a cantilever, as we have explained before, that concrete is very weak in tension. If this is a cantilever and we apply a load at the extreme, if you can see, the top part will not be the one in tension, while the bottom will not be the one in compression. In the sense that once we apply a load to this beam now, it is the top part that will be stretched out. And if the top part is stretched out, it's this stretched part that is not in tension. And if it is not properly reinforced, it will fail from this tension zone, because concrete is generally weak in tension and very good in compression. This compression zone will not fail, but as a result of this tension zone failing, it will not result in this compression zone also failing. So in other words, to counter this thing, in cantilevers, we do provide reinforcement at the top portion, while in beam we do provide reinforcement at the bottom portion, but it is only applicable to simply supported beam. But in continuous beam, the support parts are being subjected to tension, but we'll still explain that later. But I just want you to understand that once it comes to a cantilever, the tension part is the one subjected to tension, and once it comes to a beam, that's simply supported beam, the bottom part is the one subjected to tension. And two, concrete is very weak in tension. That is why we always reinforce the tension zones. So let's now coming over to combined footing and isolated footing. So I'll explain using this diagram below. But first of all, let me explain combined footing before going over to isolated footing. So first, this is the footing base, which is this one on green color. Why this is the column, and two, this column is transferring its load to this footing base. And so look at this point load now. This point load means column. This point load is something as this column. It is transferring its load to this footing base, which is this one on green color. Then we are having this uniform distributed load is the soil. It will try to resist the load that this column base is being transferred to it. So why this ones now is just the way this beam, this footing base will deflect under this column load. That's these ones, and then these ones. It's just the way this footing base will deflect under this load. So let me explain it now. So if this column transfer its load to this beam will deflect like this, meaning that this top part will be under compression and this bottom part will be under tension, meaning that we'll have to reinforce this bottom part. Coming over to this point, the only load being applied to this footing base is this soil, which is this UDL. So this UDL will try to deflect this beam upward like this, meaning that this top part will not be under tension, while this bottom part will not be under compression. Take note, at this point now, this top part is under compression, while this top part is under compression, while this bottom part is under tension. While at this point, this top part is under tension and this bottom part is under compression, meaning that within this portion we will need to reinforce this top part. Because it's this top part that is under tension. While coming over to this point now, this column load will cause this thing to deflect downward, meaning that this top part will be under compression and this bottom part will be under compression. So look at this is the bending moment diagram. This is the feedback diagram of this. Then this is the bending moment diagram of it. So that means we're having moment at the base, moment here and also moment here. So for that reason, we will reinforce the bottom to counter for this moment, and we also reinforce the top to counter for this moment, because this top part is the one under tension, and wherever we're having tension, that means we'll be having moments there, because wherever we're having tension, we'll be having moment there. See here, the tension zone is the bottom. That's why we're having this tension zone. That's why we're having a moment here, because the tension zone is at the bottom. So in this combined footing, we will reinforce the top zone to counter for this moment, and reinforce the bottom zone to counter for this moment. While coming over to isolated footing, in isolated footing, this is the column, this thing is the column, this is the footing base, while this is the soil serving as a UDL. So this is how this footing base will deflect once this column load is being applied to it, meaning that this bottom part will be subjected to tension, and this top part will be subjected to compression. Meaning, remember, concrete is very weak in tension. We will only reinforce this bottom area, leaving this top area. So this is the bending moment diagram. So if you see in isolated footing, there is no need to reinforce the top, because there is no moment on the top, there is no moment at the top, only at the bottom. So that's why we reinforce. That's why in isolated footing we will reinforce the base, not the top. While in combined footing, we will reinforce the base and the top too, to counter for this moment.